Please welcome Gülçin, who is a Postgres contributor and staff database engineer at Zeta. Apart from Postgres contributor, she is also co-founder of Women Developers in Turkey. I forgot how it is pronounced. And she, not recently, like 2023, launched DIVA initiative, Dive into AI. And she is also one of the main reason why Prague Postgres community is very active. And we always have Postgres meetup every month. So thank you, Gülçin, and thank you for your talk.
Thank you so much. Well, that was a quiet introduction. I'm happy that I don't need to do this anymore. So welcome. I'm happy to see so many people at this hour. It's like I didn't expect that. So I hope you will find what you came for and maybe better. So today we will talk about constraints. It will be a little bit like kind of back to basics type of talk and what is also new in the Postgres 18. I read the comment messages, so you don't have to. So this is like kind of a summary of what's actually new. So you'll just catch up at the end of slides. We will be done. And somebody said that I should mention I will be sharing my presentation, so you don't need to worry about the keeping this or not. So thank you for the reminder. I will share it. And so agenda looks something like this. We will talk about the catalog table PG constraint. This is where the constraints are living. We will talk about the new developments in Postgres becoming more close to a temporal database. May I say maybe? I can. And there are a lot of changes happened to not null. It became a kind of first-class constraint. So it's a new thing for not null, and there's a lot of possibilities now unlocked thanks to that. And we will talk about the not enforced. It's also a new concept. And some things are improved in the partition tables, so we will also talk about them. And Mahir already introduced me, so you don't need to know much. And I'm happy that you are here. And if you want to visit Prague, we run the meetup. We are always surging new speakers. And there is also this conference that runs annually. I think this year will be 18th, if I'm not mistaken. So in January, just before post-time, if you want to visit Prague, submit a talk. This call for papers are open. It's a pretty city. So if you haven't been there, it's a reason to come to Prague. It is really emotional for me to be always, whenever I speak in Postgres Europe, I feel really emotional. My first talk was 10 years ago. I don't know if you remember or if anybody was there in that conference. It was in Vienna. I was talking about Ansible. It was a cool thing back then. But yeah, so I'm happy to be back again. So let's start with the simple question. What is a constraint? So we have these rules to enforce the data integrity in Postgres. It's not specific to Postgres. It's kind of pretty much how relational database, one of the biggest promises to data needs to be consistent. We have to have this integrity. And when you define this table, so you can have a rule. Basically, it could be enforcing uniqueness. It can be some rule that is specific to you. And basically, these are constraints. If you think about it more generically, there are also data types. You can also restrict some sort of stuff that are kind of this data, which type of data can be entered to this specific data type, but it's really too loose to be actually really meaningful. So that's why we have these constraints in hand. OK, so the way that I kind of plan the presentation is we will start reading through PG constraint, sentence by sentence, and we will go through it what actually it teaches us, just one paragraph. So it first starts with so don't read the whole thing. You can look at the purple thing, even if not, so you don't need to read anything in the slides. I will just tell everything. So it says, it stores check not null primary unique foreign key exclusion constraints on tables. Up until Postgres 18, not null was not here. So if you check the PG 18 manual, not null was not considered one of these. So now it is. And how it looks, so there are constraint types usually. So these are all mapped for a type. So if you have a constraint, any type of constraint that belongs to this category, check constraints, foreign keys, these all have a type of their own, and they will be actually arrows in this table. So if you are new to Postgres, maybe what is catalog? If you don't know it, that's OK. So it's a kind of simply a system table. And this is the table that Postgres itself uses to keep track of the database's internal metadata. So you store your data in database. I don't know, you have users, orders, whatever. And then Postgres catalogs store the Postgres' data about your data. So it knows like which tables exist, which columns that they have, I don't know what constraints. So that's why the constraint part goes to this catalog, PG constraint catalog, but that's not the only one. There are a lot of them. So yeah, basically it's almost Postgres' internal database about your database. I like to explain this way. OK, the second sentence, it says, column constraints are not treated specially. Okay, every column constraint is equivalent to some table constraint. All right, so then it kind of teaches us there are different types here. So, but it's not different for Postgres itself internally. So basically, all the constraints are in fact table constraints. If it's a column constraint, it has only one column. Otherwise, they're all table constraints. And so for the user, if you're an SQL user, you can write different syntaxes. In the top part, what I'm trying is like I'm trying to ensure the price will be always positive. And if I write it right after the column definition in the same line, it's a column constraint. If I put it after the columns are done, kind of at the end, it is a table constraint format. But for Postgres internally, it's pretty much the same. And for the table constraints, they can have more columns. So that's the difference. And I wanted to show it so that we can actually have a look at the PG constraint table, how the rows are there, what kind of columns are there, and so on. So there will be showing this query. Again, do not try to read the query. These are all for later reference, so you can just run it later on. And I will mention things that are kind of important to our talk, or just to give you a bit of perspective how this table looks. So there is like the SVC PG constraint catalog that we are kind of working on with, and I combine it with the PG classes where like the relations data like table, indexes, sequences are there. So we join them. And what I try to get is like which table actually has these constraints, because in the previous slide we created 2 tables and 2 constraints for each of them one. So I'm trying to get like what are these constraints, what are their types, because we've seen the types already. And there is like one thing called conckey. It's very useful, right? If you are adding a constraint in like one column, it will show the number of it. Like if it's the first column in the table, or it has like first and third column, let's say, so together as a constraint, it will show that too. And there is one function, the definition of the constraint you can get. So this is the catalog itself actually recommends. So if you're having a check constraint, it says you use this function to see the definition of the constraint. It's kind of constructed in a way. And then basically you can say, OK, I want these constraints. I want to see the constraints in these 2 tables that I listed here. And then you see something like this. I expanded it because it was awful next to each other. But basically, look at it. There's pretty much nothing different. That was the point of the documentation. So you can see like which tables that they are attached to. The type is the same type. They are both check constraints, and the definition is same. And they are all defined in the first column. So I think that's like makes it easy to understand how you can actually work through these catalogs and get what you need. And then the third sentence, it says, user-defined constraint triggers created with create constraint triggers also gives an entry in this table. So like, I think we all know there's a concept of triggers, but I don't think we all, most of us probably don't know what is a constraint trigger. So it's like, is it a constraint? Is it a trigger? Is it a both thing? What is it? So that's why I think they wanted to mention it here, because it's like not something I will think about it when I think of constraints, because let's go back to the types table. Here at the end, T. So there's a type that is dedicated to this. It's a constraint trigger. So let's go back to our constraint trigger definition then. I thought it's kind of a good opportunity to talk about this concept too. So Postgres has differences for how it treats constraints and how it treats triggers. So for example, for constraints, I think during the transaction, you can actually see the internal states, because then it actually ensures there is no race condition happening if multiple things are trying to change the same thing. And so you can actually make sure it's always data integrity kept. For triggers, there is no such a thing. So, but the way that constraint trigger X is like kind of, it is in the PG constraint catalog. It's not listed in the PG trigger. So in the idea, it's kind of like a constraint. But then they are not also regular constraints as well. So because it's not, have the same sort of privilege as a constraint has in terms of MVCC aspect to it, for example. But what it has, if you can actually treat it as a constraint, it comes with some benefits to this, right? So you can actually, if it's a trigger, it needs to like fire immediately. But if it's a constraint trigger here, you can actually defer this for a later time. So you can actually change the time of this constraint to be when it will be checked to the delayed until the almost commit time. Because this is again the concept of the deferrability for the constraints. You can actually make sure it can delay until the commit. So this aspect comes from it being a constraint kind of thing. So there are some, of course, like limitations to it. It needs to be always an after-the trigger. Why? Because in the idea of a constraint, it actually checks something after the data is there. So it really can't really check before or instead of type of thing. It needs to be validating what is there already. So that's the constraint part of it. And it needs to be row level, because again, constraints are enforced row by row. So again, this comes from not for statement level, but it comes it needs to be a for row type of thing. And yeah, the type is T, we already see it. And then there are like, if you want to go more deeper to it, there is like a really nice blog from Lawrence. And if you don't know him, you should know him. If you read blogs, you should read his blogs. I really like his blogs. And in one of the blogs, he actually takes this concept and he says like, you know, why they are actually sort of, they are like kind of triggers, like sort of acting like a constraints. And he actually has a better term. He says that instead of calling them constraint triggers, we should call them deferrable trigger, because in kind of how they behave is they're like almost triggers, but you can actually defer them. So I think this concept is much better, and he explains why there is historically they were called constraint triggers in the blog. But yeah, this is linked in the slide, so you can go to him and look at it. So this is how constraint triggers, I think, work, and it's a good concept to know. I don't think many of us have to kind of deal with it or write a constraint trigger, but sometimes there are things you can do that you can't do with a standard constraint. So then you can actually write a function trigger function and use it kind of as a constraint trigger. So I think that is still very useful, but yeah, I think probably rare. OK, and that is the last sentence of the PG constraint. It says, check constraints on domain are stored here too. I was like, OK, why do we have to maybe think about it too? And again, I think it's a concept that we can refresh the topic of domain. How many of you use domain in your systems? Do you know? Yeah, very few, right? It's not really like something that's used every day. So I know that there are really big projects that I was like part of in my previous jobs that they actually utilize domains for pretty well use cases. Simplistically, it's a kind of, you create a custom data type, and you can attach rules to this custom data type. So you have a base type, like, I don't know, a text or integer or something, and you can add stuff to it. Like, you can have a not null stuff to it. You can add check constraint to it, default values. And if you have a check constraint attached to this type, you can actually see those constraints in the PG constraint. That's what the definition was saying. It's good because you can actually create this data type. So I have this simple example. So I'm creating an email address as a new data type based on a text field, text type. And it's as a regex to control, like, you know, it's a valid email or not. And then when I created table, I can use this now, the new domain that I created, email address, as a new data type, to actually give it to the email column that I'm creating. And then if I'm trying to inserting, it will actually enforce this rule. If it's not a valid email address, it will complain. So this is good. And then I will show you how we can actually see these things in the PG constraint catalog. So now there is like a little bit difference. Again, of course, there is the PG constraint catalog. But the way that I join this time, I go to the types, because domains are types. So they are more, the information there is actually, when you relate to it, it's actually coming from reference to it from the types. And again, since we know that these are like, on the domains, they are like check constraints, and then I can see those things in the PG constraint. And that's why I mark it with like C type, check constraint. And I also make non-zero there, con type ID. This means actually it's a domain. So if it's like this, it means a domain. And then I combine these things. Again, I get the constraint definition from the same system function, and I look at it. So then I can actually see I created this new constraint. It says this kind of definition, and the name is email address. So again, this is for just reference and just to show how it looks, but we don't really need to go deeper about it. And I think this is like pretty cool, basically. So far, like what I did. I just opened the documentation. I looked at the one paragraph. And then from that paragraph, we could go deeper and deeper and deeper. And I think this is really fascinating about Postgres. I don't know what you think, but so this is cool. And now we can talk about what is new in Postgres 18. So there is this giant page. And again, not really readable, and you shouldn't read. And this shows how much work goes into Postgres. Like, I mean, for Postgres 18, this is only one aspect, just the commit messages of, like, titles of the commit messages of things related to constraints. And there are a lot of nuances that goes under it, and so that's why I want to really thank everybody who actually contributed to this project. And it's really good, and we can now talk about it. First thing, because I think in the line that I have first was like temporal constraints. So I want to go back a little bit before we actually go to the temporal keys aspect and talk about what makes a database temporal. So there are like these constraints that are commonly associated with temporal databases as a criteria. If your database is fulfilling this criteria, it is kind of considered a temporal database. So this might be some like generally looking things, but these are kind of concepts that I think is important for us to understand. The first one is like, it needs to have a time period data. It needs to have represent the time with no end. So it can go to infinity, it can go to forever. So this we are almost largely fulfilled in Postgres. So we have like built-in range types. They're like, I don't know, date range, TS range, TZ range, like basically timestamp with time zone. And then you can actually represent the intervals, these periods, between the two values. SQL standard has a period type, but we don't use that. We use these ranges to cover all this kind of first item. So while we are lacking this period data type, we have the functionality covered with ranges. So we can consider the first one checked already. The second one is like the ability to define valid time and transaction time period attributes, and bitemporal relations. So this part, I don't declare to totally understand in details, but that's why we have somebody in the room today, Boris Novikov, and he is the one that I learned about temporal databases, so thank you for coming to Prague, Boris, and giving the talk, so I actually learned a lot from him. So if you have any questions about temporals, he's there. So basically, this is like to be able to do a validity interval column, they say, in your table. So you can do this partially with Postgres. So you have the range type, and if you put constraints on top of it, you can actually get some sort of time. The concept of time, the semantic of time, is in temporal databases like kind of two types. One is like system, a kind of transactional time, and the other one is like the normal time that we know is valid time. So the bitemporal aspect is like having these two together. And we have partially the valid time concept covered. But you still need like custom triggers and extensions kind of things to make them work. It's not really natively everything covered. That's why I put it as a partial support. For the next one, the transaction time, this is definitely not supported in Postgres yet. So that's why we don't have it. And the other two is what we will talk today. What makes a key temporal? What is a temporal key? How we can actually write it, how we can use it, what is the benefit to it comparing to before. And the rest is like kind of more in detail, so we don't need to go through that. But basically, what I can summarize from is that Postgres very much actually supporting the building blocks of a temporal database, which is not surprising to me because whenever I learn something new, I look back to Postgres and things are almost there, or the building blocks are there. So there's a lot of, I think, this really excites me because there's a lot of potential where how far we can actually take this endeavor. So the keys, temporal keys, are a beginning step, let's say. Like, I'm not considering the range that we already have, or range operators, because it's also important. We can actually go through these operators. So it's a good time to actually be excited about this. I think we can go further with temporal database. Again, this is a rule or like kind of what I learned about querying temporal database from Boris. He said, queries to a temporal database return facts that were, are, or will be actually at a time that may differ from current time. So I think the understanding of a time as a dimension is not really like what we think when we are building relational databases. So it's a new concept, but it is there. And I wanted to maybe kind of summarize what I kind of understand. So if you are thinking a temporal database model, so each data row needs to have an associated time period with it. And the periods are, the way that they describe usually, is like closed and open. So they can actually close to each other, adjacent to each other, but they shouldn't overlap for one business key, they call. And I'll explain what is a business key later. So basically, what time database is called, temporal database is called business key, is like something that you want to keep track of it over all the time. So let's say you have a product ID, and you want to know this product ID over a historical time of periods of validity. That is your, basically, what is your main interest. So they call it like business ID, from what I understand, business key. And then based on that, periods for this same business key can never overlap. So that's why we have this without overlap clause in the new primary key, because they should never overlap. So that is the basically main fact about this model. And then, as we talked, there are like different semantics of time there, system time, transactional, and valid time, and there's a lot of differences between, but we will not go there. And then while you, let's say you design this model, and you have to get the data, that's also like retrieval of this data is also different than standard retrieval that we know. There are like point-in-time queries. So if you can actually model this database, you can actually do point-in-time queries. You can have like event logs type of things, like history of an item, history of a row, history of an object, history of an attribute, and so on. And you can actually use one input from one to another, so you can feed these things together. So there's like really a lot of things to be, learned if you are trying to model some temporal database. Also, modifying is also different. So if you do normal update, and if you do an update in the temporal database, it's different. And nothing is deleted from temporal databases. It is like their periods are closed. So when the periods of its validity is done, basically, it's kind of deleted for us, for the temporal databases. So this is a new concept, and I think we could all enjoy looking at it. And now with Postgres 18, now we have stuff. And I will show you how it looks. So in the SQL 2011 standard, this was temporal features were added. Now Postgres is supporting it. We are using the without overlaps for primary keys and unique keys. And I will talk later for the foreign keys as well, that there is the period clause for them. So what we have now is like a temporal referential integrity in the foreign keys, and also the same thing for the primary key. So together, without overlaps and period, makes this a kind of fully supported temporal keys. So how does it work? It's really simple. So I put the example here, like how can you write the primary key? There's an ID column, and there's a valid at column, and then without overlaps. So without overlaps is actually only applicable to the valid at column. This is the column that you need to, for now in Postgres, you need to have it in the range type or in the multi-range type. And then this is like how you can actually write it. So it means that you can have multiple IDs. So that is, but together, the time periods in the validate, this should never overlap. And now there's a simple example I wanted to show. It's much more clear when we actually talk about it through an example. So I create a table, rooms, and I want also a booking table. So you can't book a table in the same time, right? So the rooms are available there, but you can't really book for the same table, the same room. So that is the scenario that we will work. Also, maybe you noticed that we have to use the B3 gist extension here. Why? Because these keys are actually not using the B3 indexes. They are using gist. The way that gist itself, before this, basically implemented in the Postgres 18, people were still doing the temporal things with Postgres, but what they were doing is they were using excluding kind of constraints with gist. So they were able to have these things because thanks to gist, this already covers this method already. So basically, if you want to use this, when you use gist with exclusion constraints, you were able to ensure that there is no time overlap on any of these distinct values of the primary key. So that was already there, and now that's how it's actually implemented. So that's why we have to use this extension. Anyway, so I'm creating the primary key in the bookings table. I have the room ID, and during, that's my period, and I don't want any overlap here. And then I now enter 2 rooms. One is blue room, one is the green room. And if I'm trying to now insert a value that will overlap for the same room ID, it will actually fail. So I'm trying to insert now, after I had these 2 values that I inserted for the blue room, I'm trying to insert again, like, I have this blue room, but the time that I'm trying to insert is actually from like 10:30 to 10:45, but it's actually conflict with the first entry that I had there for the period. So it is like 10 to 11. So I can't actually enter, so it will just complain. It complains very well. It is really clear. It says like, hey, you can't do this. It conflicts with what we have already there. So this is cool. And then if I try with, of course, different room ID, which I didn't enter anything in there for green room, I'm using the same range, then it shouldn't be rejected. It is OK. You can edit. And in the implementation now, currently, it is also rejecting empty ranges. Maybe later on it will be fixed or improved, I don't know. But the current implementation doesn't accept empty ranges, so I can't actually enter it. So I wanted to show that as well. So basically, what we achieved, now we can actually enforce 2 bookings over, like no 2 bookings can overlap in the same time for the same room. So it actually takes a lot of thinking, a lot of different logic, and just put simply with a primary key concept. OK, and then there is also I said there are 2 legs to it. Like one is like how we do the primary and unique temporal, and how we also can do referential integrity with foreign keys as well. So you can write something like this, exclude using gist again. I'm sorry. The way that we were doing this before we had this feature, we were using it like exclude using gist. It's the same thing. Now instead of doing it this way, we do it with what I showed earlier. So this was the summary, and this is what I wanted to show, how you can actually write a foreign key constraint in a temporal manner. Now we can actually make sure this room availability type, let's say I imagine in this bookings there's an availability that I set it in the primary key in the primary table, and there's a room availability thing, and you can actually also make sure whenever I book something, it needs to be part of this availability time with the period clause. And of course, there's some limitations. This is still new implementation, so you can't do some actions like what you can do with normal foreign keys, like on update, do this, or I don't know, cascade, and so on. So you can actually not use that yet. But this is a start. It's a good start, so it's cool. And another new thing, it's not enforced. I think it's like anybody using not enforced yet? Because when I first heard it, like, why do we need not enforced? Because we have not valid, right? Like, I was like, OK, we have not valid, and we have something less than not valid, or how does it work? So I think it is very clear why we have not valid. So when you create a constraint, you don't want it to be checked immediately for various reasons. One of the main one is like, you don't want to lock the table. You want to avoid the access exclusive lock. And I had a talk about this. It's like anatomy of table level locks in Postgres. So if you're interested in this topic, I actually go through lengths of like how you can avoid getting access exclusive lock while you do schema changes or something. So that's why not valid is perfect. We needed this. And now we have we go a bit further by having the not enforced. So what is the difference in between? So if you are adding a constraint is not valid, as I said, so we don't check it at the creation, and we validate it later. But it is valid from the moment that you add it. So if you want to insert a new data to a not valid constraint, it will be checked. From that moment on, it's actually valid for the new stuff. But for not enforced, it will be never checked until you enforce it. And so it gives you a bit greater control, let's say, that it will be never checked. You know that. It is there for you, but you can decide to do it, maybe enforce it later. For check constraints, though, you can't really change the enforceability of the constraint if you add it. So you have to drop it and recreate it if you want to change the thing. And there is also now, where do we actually store this information? It, again, is in the PG constraint catalog. So there is this con enforce, so constraint enforced or not. We can actually see this from this flag. And so also, I think this is like more, it's more useful when a foreign constraint is created on the table, because normally when it's created, there are like triggers that is added. So to be able to maintain the data integrity, creating a foreign key constraint means that it also has this triggers that comes with it. So if you have it as a like not enforced, now you don't really have to check these things. So that means that triggers will actually not be created for this when you have the foreign key constraint as a not enforced. And it will be marked as not valid, which is like good if you really want this type of reaction when you are creating a foreign key. You can actually change these things. So you can do an enforced thing, an enforced foreign key to not enforced. Then if you do that, the triggers that was created when it was enforced, that will be dropped, and the constraint itself will be not valid. And if it was like not enforced when you created it, and now you want to enforce this thing, if there's a trigger missing, that will be created, and the constraints will be then changed to valid. So it actually gives a lot of flexibility, the way that we can actually handle it, but it's still, I don't know. Yeah, it's a kind of, we need to think about it if we want to use it or not, or when we can actually use it, besides like giving us flexibility about enforcement of it. Okay, there was also like collation-related fixes. String comparisons in Postgres depends on collations, and non-deterministic collations are they can produce surprising results. So to prevent this problem, Postgres 18 now requires in the primary key and foreign key relationships, either they should use deterministic collations, both parties, or they should use the same non-deterministic collation on both sides. And so this is good, but what is, I think, maybe important for today, we don't really need to maybe think about it, but if you are using pgdump and pgupgrade, which probably most of us use, this might be a problem, so you need to think about it if there is something that is interesting to you here with the collation. So before you upgrade, think about it if you have to fix something and look at the collations before you do that. Okay. And now the other changes. I think that another group of changes that came is like how not null is reworked. It's reworked. And before, it was not part of the PG constraint catalog. It was part of PG attribute, and it was kind of flag. It's like null or not null. So the way that it was treated, it was not like kind of constraint. It was something of its own. But now it is actually like a proper constraint. So what does it bring to us? Like, what does it mean? OK, there's a new type that we can see, not null. And people can actually name these constraints now. But what is actually the real benefit is now we can use all the things that comes with becoming a constraint. So if you're a constraint, there are things that you can actually do. First thing, it actually now shows when you do describe the table, you can actually see a new section, not null constraints, which is new. And you can see what are they. They're also thinking maybe it's too busy, too noisy to put all these not nulls together. But yeah, currently it is visible. And then it's actually, how will I propagate this to the other tables? So if there's an inheritance, if there's a partition, how will it work together? So that's changing. And there is like, you can actually control this. And what else you can do? Not valid. And that's, I think, the biggest thing with becoming a constraint. Because if you were having, let's say, you were trying to add a not null to a column before, and to avoid this, getting log contention, getting access exclusive log, blocking your table, you had to do what you can do, that you could create a check constraint as an invalid, and then you actually change this data to update the nulls, and then you can actually then validate it, and then add the not null constraint. So this is how we were trying to avoid directly adding not null. And so now we don't need to do that anymore. We can just add the alter table, add constraint, not null, and not valid. That's, I think, is really, really great. So we don't need to do all this dance around it. And how the inheritance works, it pretty much works like how we would expect. So if the parent itself is valid, child cannot be invalid. So that's the thing. It kind of follows a similar logic for enforced and not enforced. And then the validity itself is also stored in the constraint catalog, PG constraint catalog. It's in non-convalidated. You can see if it's validated or not, and it changes when you validated it. And for the dump and restore, you don't need to worry about it. There's nothing changed of how you will be affected by this. Dumps are, I think, handled first not nulls are dumped, invalid ones, and then validates them after the data load, like how it's done for the check constraints. So nothing is changing there. You don't need to worry about it. And then, of course, as I said, like inheritance changed, but I wanted to also show like how it works. Let's say if it was not inherited first, it was like created as like non-inherited. And if you are now inheriting it, what does it work? It will actually add the missing constraints later to the inherited table, the child table, let's say. And if you started from like inheritance and now you don't want to inherit, when you switch to non-inherit, and then it will just drop the constraints from the children. And basically, it cuts the ancestry line. So it almost becomes in the child table a kind of local constraint to the child. The parent is kind of gone. So this is how it is treated. And another thing, this is not about any more not nulls, but I think it's actually a nice feature again, not valid foreign keys on partition table. So when they were actually developing foreign keys, they didn't do not valid foreign keys. They didn't do it for the partition tables. It was, I think, more work at that time. But now, thanks to this, what we can do, we can actually do per partition validation. So instead of adding, when you add this foreign key in the partition table, then it would actually be validated all at once. We really rarely do want that. So you can now validate partitions independently, and then obviously it will reduce the log scope or the duration and the time. And then you can, if you want it, you can also do it in the top level, in the parent level. You can do everything at once. It's up to you. And then, of course, that opens another improvements in this thing. Once you have the not valid now, you could actually think of maybe not enforced as well, because as we've seen that the trend is going that way. So maybe it will be eventually implemented too. And yeah, I talked a lot, and this is the last slide. So thank you for bearing up until this point. The last thing that I wanted to mention, this is was a restriction that they actually didn't intend to restrict at the beginning, I think, but that was kind of like how it was. So you were not able to run this before, alter table, only parent drop constraint. So you were not able to run a drop constraint from a parent table. Now you can actually do this. So the constraint, it is removed from the parent, but you don't actually leave the children's constraints. You don't touch them, they stay there. But what happens is, if there is a future inheritance happening, the new newer ones will not get into this constraint inherited because it doesn't exist, which is kind of how it should have been worked probably before. But of course, adding a restriction only on the partitioned parent is still not allowed. And that is what it is. And so this is all the list of what changed in the constraints. I know it was really text heavy. It's a lot of text there, a lot of, hard to read. But yeah, I hope you enjoyed it. So thank you.
Thank you, Gülçin. We don't have that many constraints on questions because a lot of time.
Thank you for the talk. Can you enlighten me, what is the point of having a not enforced check constraint?
Yeah, exactly. So I also thought why it should be, but then I read it a little bit in the commit. For once, it kind of considered documentation of how your data model should look like for applications. So you can actually enforce these things through your application. But you don't enforce it immediately when you create. Maybe you will enforce them later, but you don't want to do it later. You don't want to do it now, but you still want to keep this mental model already in your database model. But I think, if I'm not mistaken, maybe if there's a hacker in the room that can actually approve this or not, the optimizer will take the hint from this information, from what I understood. So it will actually think that this shouldn't be, it's not enforced, but it should be the way that optimizer understands this. This, I'm not 100% clear. I just remember reading this in the commit messages, but I think that could be a benefit. But I asked the same question to myself, why? But yeah, it all comes to the deferability aspect of it.
Hi, over here. If you set a foreign key constraint not enforced, do you know what happens to locking on the reference table?
So basically, if it's not enforced, it's not being logged because it's not enforced, it's not checked. The integrity check is not happening.
No, I mean when you alter table change constraint from enforced to not enforced.
So I will go back to
so
look.
I can.
Yes, that was actually. I'll show you. Here, so if you were like first didn't enforce it, and then now you want to change it to enforce, it's the last item. So if there's a missing trigger because we didn't, if it was not enforced, this triggers that is actually checks for these constraints were not created. So once you change the status from not enforced to enforced, it will actually create the missing index, missing checks, triggers, and then it will be validated. At that point, it will be valid, and that means that it will be going through validation. But up until that point,
so the question is about the point before that the enforced to not enforced. This will drop a trigger, right?
Yes.
And one of those triggers will be on the reference table, not on the table that you're actually altering table on, right?
Yes.
Okay.
I think. Yeah.
So my question is maybe actually on that third point around locking behavior there. Does that, so not enforced to enforced, if the constraint becomes valid as of when that runs, does that imply that there needs to be a lock taken for that validate to happen that whole time?
Yes,
And
because if you are validating it, it will act exactly like as if you are changing an invalidation, invalid to valid. So the validation will happen the same way. So whatever the locking mechanism for goes to valid, which validates the the data, new data, it will go through the same thing basically.
And so maybe a quick follow-up, is there any option for it to be in this not enforced but, or sorry, this enforced but not valid, in order to separate those?
Valid.
Since I assume if you make a constraint not valid, is it correct to say that that's enforced but not valid?
No. I think if it's enforced from not enforced, that needs to go to, I mean, from what I understand, because I don't exactly, do the implementation, it won't be. So when you're enforcing it, it will be also marked as valid, and that will probably trigger the validation. That's my expectation. But we can check this deeper. I don't know. I have to. This is like the detected from reading through messages of comments. I will write about this topic soon, so then I will actually have better answers. And if you guys are not following Planet Postgres, there's an aggregator. I always tell it after every presentation of mine. It aggregates all the blogs that community people write. So you can see different companies, different people from all around the world writing blogs about everything almost. So for the Postgres 18, there was a lot of blogs about like what changed, what people who actually write. For example, there was a blog from Alvaro, who was one of the people who worked on this NOT NULL rework. And he actually explained it so well. And yeah, I think it's good if you don't know it, you should check the Planet Postgres too.
Okay, so if there are no more questions, then let's thank you, Gülçin, and your gift.
Oh, thank you.